Lesson 29, the Central Limit Theorem. Example 4. The duration of human pregnancy follows a normal distribution with a mean of 274.5 days and a standard deviation of 13.6 days. An obstetrician's practice is currently treating 25 pregnant women. Find the narrowest interval that has a 98% chance of containing the mean duration of pregnancy for these women. Well, here to find the narrowest interval is the range of values from L to U, which is symmetric about the mean. So the answer for the narrowest interval would be the two values, L and U, which define the interval. Now what's special about this interval is that it has a 98% chance of containing the mean duration of pregnancy for these women. The 98% tells us that 98% are within the interval from L to U, which leaves us 1% below the interval and 1% above the interval. Now this interval is containing the mean duration of pregnancy for these women, that is X bar. Well, we know that the results of the central limit theorem can be applied to probability problems involving the sample mean. Thus, we know that the sample mean follows an approximate normal distribution. Hence, we can use our normal probability distribution to answer this question. And we also know that the mean, mu sub x bar, for the sample means is the same as the mean for the population from which it was sampled. Thus, mu sub x bar would equal the 274.5. Also, sigma sub x bar, the standard deviation of the sample mean, is equal to the standard deviation of the population from which it was sampled, divided by the square root of n, the sample size. So in this case, the standard deviation is 13.6, and n, the sample size, is the 25 pregnant women. So sigma sub x bar equals 13.6 divided by the square root of 25. Now back to the question. We want to find the narrowest interval that has a 98% chance of containing the mean. So the interval is the range of values from L, the lower limit, all the way up to U, the upper limit, such that 98% are contained in between. This leaves us with the remaining 2% outside. Now the narrowest interval is symmetric, so this 2% is divided in half, which gives us 1% below the interval and 1% above the interval. Now, when we know the percentages, and we're trying to find the particular values, in this case L and U, we need to use the inverse norm command to find that. Now, an interval is made up of two values, L the lower limit and U the upper limit. Thus, we need to do the inverse norm command twice, once to find L and a second time to find U. So starting with L, there are three values that are input into the inverse norm command. The first, k over 100, where k represents the percentile. That is the percentage of the normal distribution that is less than the number we're trying to find. So L only has this lower 1% less than it. So it falls at the 1 percentile. So k is 1. So we can enter this into the calculator as the 1 divided by 100, or we could enter it in decimal form. 1% would be 0.01. The mean, mu x bar, is 274.5, and the standard deviation, sigma x bar, is the 13.6 divided by square root of 25. So entering this command into the TI-84 calculator, we'll find L, the lower limit of the interval. To find U, the upper limit of the interval, we just do the inverse norm command again, but this time using k as the percentile, or a percentage that is less than the value of U. Here, the entire middle 98% is less than U, and the lower 1% is less than U, giving a combined 1% plus 98%, or 99% of the curve less than the value of U. Thus, k would be 99. So we can enter this into the calculator as 99 divided by 100, or the decimal version of 99%, which would be 0.99. The mean was 274.5, and the standard deviation is 13.6 divided by square root of 25. Now we can enter these values into the TI-84 calculator. The inverse norm command is found in the distribution menu. To get there, we would press second, DISTR, arrow down to inverse norm, press enter, For L, we would enter in the 0.01, comma, 274.5, comma, 13.6 divided by second square root 25, close parenthesis, enter. Now we can find U by doing the inverse norm command again. Second, distr, arrow down to inverse norm, enter, 0.99, comma, 274.5, comma, 13.6, divide by second square root 25, close parenthesis, enter. We now have the value for U. So L rounds off to approximately 268.2, and U rounds off to approximately 280.8. Now the units given to us in the inverse norm command are the same units as the random variable in the question. In this case, duration of pregnancies were measured in days. So these values are 268.2 days and 280.8 days. Here we'll carry the extra decimal place because we are looking at the sample mean x bar, which is continuous, so we want to carry that extra decimal place of accuracy. Thus, we can give our answer in words of the problem. Thus, the narrowest interval that has a 98% chance of containing the mean duration of pregnancy for these 25 women ranges from 268.2 to 280.8 days.